Good evening. Tonight we're going to start with lesson 36 in our fraction unit. I can represent the multiplication of an n times a over b as using the associative property and visual models. So we're still going back like we did with the last lesson. And if you look over here, basically what we're going to be doing is repeated addition to show multiplication and then showing multiplication for repeated addition. So right here is repeated addition because 5 plus 5 plus 5 is 15, like 3 times 5. So those are equal. And the same goes when we multiply with fractions. And so like we have 3 groups of 5, 6. We do when we're adding this repeated addition. 5, 6, 5, 6, 5, 6, which equals 15 over 6. And remember, we're not going to be leaving answers of a fraction greater than 1 or an improper fraction. We have to turn them into mixed numbers. All right, so let's get started. All right, draw a tape diagram to represent 7/8 plus 7/8 plus 7/8. So we have 3 groups of 7/8. So what we're going to do is we're going to draw a tape diagram. Whoops. And we are going to cut it up in thirds. Why am I cutting it up into thirds? Because I have 3 7/8. 7/8 here, 7/8 is here, and 7/8 is here. So that's my tape diagram to represent 7/8 plus 7/8 plus 7/8. And all of this together is equal to 21 over 8, 21/8. Now, on the bottom, it says write the multiplication expression, which is equal to 7/8 plus 7/8 plus 7/8. So remember, this is just saying we have 1 group, 2 groups, and 3 groups. So we've got 3 groups of 7/8, okay? And so 3 times 7 over 8 is 21/8. And then we would turn those into into a mixed number. Rewrite each repeated addition problem as a multiplication problem and solve. And then we're going to express it as a mixed number. Okay, so let's turn this into a multiplication problem. So how many do we have? We have 1, 2, 3, 4. We have 4 groups of 7/5. So how would we write that? 4 times 7/5. So which is equal to 4 times 7 over 5, which is 28/5. But we can't leave 28/5 because that's a fraction greater than 1, an improper fraction, so we have to change this into a mixed number. And how we do that, guys, is what we're just going to start pulling out those holes until we get close to that numerator, which is 28. So here we go. We've got 5/5 plus 5/5, which is 10/5. We're not there yet. 5/5 is 15. Not there yet. We are close. We have got 20/5. I can do one more, which would give me 25/5. And I've got 3/5 left over. So how many do I have? I have 1, 2, 3, 4, 5 holes and 3/5 left over. So 28/5 is equal to 5 3/5. All right, we're going to do the same thing again, and we're going to make this repeated addition into a multiplication problem, then we're going to solve it. And we want our answer to be in a mixed number. So how many 5/12 do we see? We see 1, 2, 3, 4, 5, 6 5/12. So this is going to be 6 times 5/12, which is saying 6 times 5 over 12, which is equal to 30 twelfths. But we can't leave 30 twelfths as an answer because that's a fraction greater than 1, or what we call an improper fraction. And now I am going to start pulling out those wholes that I can get out of that. So I get 12 twelfths, that's one whole, plus another 12 twelfths, and that gives me 24 twelfths. And that means I'm going to have to stop because if I added another one, I would go over 30. So that means I'm left with 6 twelfths. So I have 1, 2, I have 2 wholes and 6 twelfths left over. But if we look at that, boys and girls, we notice that 6 twelfths can be reduced, and the factor that they share is 6. So I'm going to divide the top and the bottom by 6 to get 2 1/2. All right, we're going to solve using any method, but we have to make sure our answers are either as a whole number or a mixed number. So let's get started. We're going to do 7 times 2 ninths. Now, 7 times 2 ninths is just saying we're multiplying the numerator by 7, and we're over it by 9. This becomes 14 ninths. And now it's a fraction greater than 1, or an improper fraction, so we're going to pull out those wholes that we can get as close as we can to 14. So what we've got here is I can do 1 whole, that would bring me to 9. And if I added another 9 ninths to that, it would bring me 18 ninths, and that's too high. So all I have left over is 5 ninths. So this is equal to 1 whole and 5 ninths. Now 5 ninths is in simplest form. We can't reduce that any more than what it is. There were 11 players on Mr. Majorani's softball team. They each ate 3/8 of a pizza. How many pizzas did they eat? All right. So remember when we did the word problems, we always want to try to do the read, draw, and write, right? We want to read it to make sure we understand it, and we reread it several times to really understand and maybe circle and underline important information. Then we can help to draw a picture, and then we write about it. So let's check this out. There were 11 players, all right, that are on this team, and they each ate 3/8 of a pizza. Now we want to know how many pizzas did they eat. All right, so now let's draw some little baseball players. And how many are we going to draw? Well, we are going to draw 11 because that's what it says, 11 players. So I've just saved some time and made 11 softball players. And each one of those guys ate 3/8. All right, again, to save time, I stopped it and I finished it. 3/8. Each one of them ate 3/8 of a pizza. So all of this together is basically saying we've got 11 groups of 3/8. So we are going to do 11 times 3/8, which is equal to 11 times 3 over 8, which is equal to 33/8. But now we can't leave this as an improper fraction or a fraction greater than 1. We need to turn it into a mixed number. So we got to pull out those 8s that are in those holes that are in 33/8. So let's start doing that. So we've got 8/8 plus 8/8. That would give us 16/8. Then another one would give us 24/8. Another one will give us 32/8. So we're very close, but cannot add another 8/8. So we're left with 1/8 left over. And how many holes do we have? We have 1, 2, 3, 4 holes and 1/8 left over. All right, a bricklayer places 12 bricks at end to end along the entire outside length of a shed's wall. Each brick is 3/4 foot long. How many feet long is the wall of the shed? All right, so we've got 12 bricks, and it's going end to end. And each brick is 3/4 foot long. Then they want to know how many feet. All right, so let's try this out. So we've got 12 groups of 3/4. So we've got 12 times 3/4, which is really saying 12 times 3 over 4, which gives us 36/4. We cannot leave 36/4 as an answer because that's an improper fraction or a fraction greater than 1. So we have got to pull out the wholes from that. All right, so how many wholes do we have in 36/4? Well, guys, we could just do a simple division. We can divide 4 into 36, which would give us 9. You could simply divide that. Or we could do it this way and say, all right, we got 4/4 plus 4/4 gives us 8/4. That's 12/4. That's 16/4. Just to save time, that's how many 4/4 are in 36/4. So there was 9 holes in 36/4, which we could have just simply divided. And how many times does 4 go to 36? 9 times. 4th graders, you're my only hope. Do the best you can on the next set of problems. All right, draw a tape diagram to represent 2/3 plus 2/3 plus 2/3 plus 2/3, and then write a multiplication expression equal to 2/3 plus 2/3 plus 2/3 plus 2/3. And I want to see your tape diagrams and your multiplication expressions tomorrow. Rewrite the repeated addition problem as a multiplication problem and solve it, and make sure your answer is a mixed number. And I want to see your work tomorrow. So solve this 11 times 2/3 using any method, but make sure that your answer is either a whole number or a mixed number. And I want to see your work tomorrow. Our Star Wars friends, thank you for doing your best job tonight on those problems. Have a wonderful night, guys. May the Force be with you tonight and always.